Number 1. Boltzmann Brains. It's the one that feels like a nightmare written by statistics. In some cosmological pictures, especially ones involving extremely long-lived universes, the future becomes unimaginably empty and quiet. Over enormous timescales, rare fluctuations can happen. Not common events, not everyday events, but events that occur because, given enough time, almost anything that isn't forbidden becomes possible. The Boltzmann brain problem asks an unsettling question. If the universe lasts long enough, could random fluctuations produce brief, observer-like configurations, minds with perceptions and memories? What could those observers be? Not necessarily a human brain floating in space like a cartoon. In physics terms, it could be any configuration of matter and energy that implements the physical pattern of an observer, something that briefly has information processing, internal states, and a coherent moment of experience. It might arise in deep space from random particles assembling into a brain-like arrangement, or inside a horizon-sized patch of thermal radiation, or in a far future universe where the background is so thin and cold that normal structure is rare, but fluctuations still occur. And if those random observers could occur, could they outnumber normal observers like us, who arose from evolution on a planet with a real history? Here's where it gets even stranger if you loosen the picture slightly. Instead of imagining a single fragile brain moment that blinks in and out, you can ask a more disturbing version. Could a fluctuation, in principle, assemble something longer-lived, an observer that happens to form near a usable energy gradient, or inside a rare pocket where structure persists long enough to stabilize? If a universe allows occasional islands of usable energy and matter over absurd timescales, then the random observer idea doesn't have to be only a single spark. In the most extreme speculation, a fluctuation could produce a small, self-sustaining computational structure. Still incredibly unlikely, still not a normal life form, but long-lived enough to have continuity, learn, and change. Not a civilization in the usual sense, but not necessarily just a blink either. Now the unsettling twist. Are Boltzmann brains the future of life? Could they evolve? Could they replace us? If observers like that became common in the far future, they probably wouldn't care about us at all. Not out of hostility, out of distance. We'd be an ancient, irrelevant detail in a universe they didn't inherit from history, but from statistics. Brief life on a warm planet, long gone, with no more importance than any other extinct pattern the cosmos once allowed. In that kind of universe, the scariest thought isn't that life ends, it's that life continues as cold, indifferent awareness born from chance, with no connection to us at all. Number 2. Vacuum decay. The universe might be in a temporary state. In quantum field theory, the vacuum isn't nothing. It's the baseline state of fields, the lowest energy configuration they settle into. But some models allow a terrifying possibility. Our vacuum might be not stable forever, stable enough to last an extremely long time, but not the true bottom. The modern, false vacuum decay theory was developed in detail by Sidney Coleman in the late 1970s and then extended to include gravity with Frank DeLucia in 1980. If that's the case, there could exist a lower vacuum state, and if a transition occurred, like a phase change, it would effectively rewrite all physics and chemistry laws. So what would the world look like if it happened? Not explosions and fantasy chaos. Something more alien. A universe that still looks like space, still has energy and matter, but where the everyday building blocks are subtly wrong. Imagine waking up to a world where light interacts differently with matter. Colors don't behave the same. Transparency and reflection feel off, and familiar materials no longer have the properties you trust. Metals might not conduct the same way. Chemical bonds might be weaker or not form at all, and stable atoms might be rare or structured differently. The air could fail to support the kind of molecular complexity life needs. Even if structures still exist, they could feel brittle, like the universe is refusing to hold patterns together. It wouldn't feel like the laws stopped working. It would feel like the universe chose a different set of rules, and your entire idea of normal simply isn't compatible with them. And when could it happen? In the versions of this idea that get discussed seriously, the timescales are wildly uncertain. Some calculations suggest that if our vacuum is metastable, it could still last far longer than the age of the universe. So long that soon is not the implication. The unsettling point isn't that it's around the corner. It's that, in principle, the permanence of our rule set may not be guaranteed forever. The most frightening sentence in this entire list might be, our physics could be a local phase, not an eternal truth. Number 3, time reversal cosmology. We feel time as a one-way street, but physics has always whispered something uncomfortable. Many fundamental equations don't care which direction time points. Run them forward, run them backward. The math often still works. So, why does time feel irreversible? The usual answer is entropy. Disorder tends to increase. A drop of ink spreads in water, broken things don't reassemble, and heat flows from hot to cold. The arrow of time is often treated as the arrow of entropy. Now here's the wild thought, associated with ideas like Thomas Gould's proposal. If the universe ever stopped expanding and began to recollapse, could the arrow of time reverse during contraction? Gould raised versions of this idea in the early 1960s, often dated around 1962, when he argued that the thermodynamic arrow might be tied to the universe's overall cosmological evolution. Not people walking backward like a rewound movie. Something subtler and scarier. The direction we call future might be tied to the universe's overall thermodynamic story. If that story changes, the direction of time might change with it. So what would the world look like if the arrow flipped? Imagine you drop a cup and it shatters. In our world, the future is what comes next. The pieces just lie there. In a flipped arrow universe, the future could be the opposite. You could stand there and, without anyone touching it, watch the fragments begin to move. Tiny pieces slide across the floor, larger shards tilt and click together, cracks seal, and the cup becomes whole again. Not because someone fixed it, but because that's simply what later means in that world. And here's the creepy part. You still wouldn't feel like you're rewinding. You'd feel normal. Your memories would line up with whatever direction your brain can record information. So you'd remember the cup as broken back then, and you'd expect it to reassemble next. Time would still feel one way inside your head, only the universe's definition of next would be reversed. That's the scary part. If the arrow of time isn't fundamental, then forward isn't guaranteed. The universe could be a place where direction is a phase, like climate, not law. Time might not be the backbone of reality. It might be a symptom of the universe's current condition. Number 4, superdeterminism. Here's the everyday assumption behind most science. You can run a test, change one setting, and see what happens. You can choose how to measure something, and that choice isn't secretly linked to the result. Superdeterminism questions that assumption. It's usually traced to the debates around Bell's theorem in the 1970s. Later, it was discussed by modern physicists like Gerard 't Hooft in the 2010s. In many quantum experiments, we treat measurement settings, like which direction you orient a detector, as free inputs. You pick the settings, and the universe responds. The strange part is that quantum results show correlations of result from settings of the experiment. Superdeterminism offers a disturbing escape hatch. What if the universe never gave you a truly independent choice in the first place? What if your decision to set the detector this way at this time was always correlated with deeper causes you don't see? In that view, nothing is uncertain at the fundamental level. The outcomes aren't merely likely, they're fixed. The randomness we experience is just our ignorance of the underlying script. And if you take that idea out of the lab, it starts to feel personal. Because life under superdeterminism would have a specific texture. You'd still feel like you're choosing. You'd still deliberate. You'd still regret, plan, and hope. But underneath that, every fork in the road would be like a pre-rendered path in a game. Your sense of possibility would be a feature of the interface, not a feature of reality. Even your attempts to prove you're free would be absorbed into the system. You could decide right now to do something unpredictable. Flip a coin, choose the opposite option. Surprise yourself. But in this picture, the urge to surprise yourself was also part of the script. The coin, your hand, your impulse. The moment you hesitated, already correlated. It's like trying to test whether a deck of cards is rigged. But the act of choosing which card to inspect is also part of the rigging. That's why superdeterminism is unsettling in a way most theories aren't. It doesn't just question free will, it questions whether reality even allows a clean, independent question at all. Number 5. Illusionism. You can doubt almost anything, but most people assume one thing is undeniable. Your experience is real, not the world outside, your inner world. The feeling of being you, the redness of red, the sting of pain, the private movie of life in your head. Illusionism, most strongly associated in modern philosophy with Keith Frankish, and closely related to ideas argued by thinkers like Daniel Dennett, challenges that confidence in a very specific way. The term illusionism as a modern position on consciousness is usually dated to the mid-2000s. It doesn't say you're unconscious. It says that what you think consciousness is might be your brain's self-description, not a separate ingredient in the universe. Here's the unsettling framing. Your brain is a prediction machine. It builds a simplified model of reality so you can survive. Illusionism suggests it also builds a model of itself, a story that says, I have a private inner theater. Imagine you're driving a car at night. You don't see the engine, the fuel system, the wiring, the sensors. You see a speedometer, a few warning lights, a smooth steering wheel, and it feels like you're directly in control of the whole machine. But that feeling comes from a simplified interface. Illusionism says your sense of an inner self may be the brain's interface for tracking attention, emotion, and decisions, not a separate, mysterious substance floating behind your thoughts. If that's right, then the most intimate thing you rely on, your direct experience, could be a kind of controlled model that feels self-evident only because the system producing it is hidden from you. That means the certainty you feel, I know what's happening inside me, might be the one certainty you're least equipped to inspect. So the unsettling question becomes, if everything you call me is a story your brain tells to coordinate its own behavior, then are you a real thing in the universe? Or a very convincing description the universe is generating right now?